Hey, this is Mrs. R with your Ellensburg High School Chemistry Scientific Notation lesson. Hey, so I'm going to start with the folks over at Veritasium. They're going to explain to us what is scientific notation and why do we use it.
In science, we often need to deal with some very large numbers. For example, the mass of the sun. That is the mass of the sun. A 2 followed by 30 zeros in units of kilograms. That is 2,000 billion kilograms. There has got to be a better way to write that. Can you imagine if there wasn't? So to represent large numbers easily, we use something called scientific notation. Scientific notation takes advantage of powers of 10. For example, 10 to the power of 2 means take two 10s and multiply them together, and you get 100. 10 to the power of 3 means multiply three 10s together, and you get 1,000. When it's 10 to the power of 2, our final answer has a 1 followed by 2 zeros. When it's 10 to the power of 3, our final answer has a 1 followed by 3 zeros. 10 to the power of 4, again, 4 zeros. So if we wanted to represent the mass of the sun in scientific notation, we would need 30 zeros. So we represent that using 10 to the power of 30. This means we're multiplying 10 by itself 30 times, which gives us a 1 followed by 30 zeros. But the mass of the sun is actually twice that. It's 2 followed by 30 zeros. So we can multiply 2 by 10 to the 30 in units of kilograms, and that is the mass of the sun. It's a lot easier to write, and it takes up much less space on the page. The other problem is we have to deal with some very tiny numbers. For example, the mass of a proton is that is the mass of a proton. 0 point, and then there's 26 zeros, and then 1673 kilograms. A truly tiny number. So how do we deal with this? Well, again, it's using a similar trick. If we raise 10 to the power of minus 1, it means divide by 10, not multiply by 10. So this means divide by 10, which gives you 0.1. 10 to the power of minus 2 means divide by 10 twice, which gives us 0.01, a hundredth. The exponent here tells you the number of places to the right of the decimal that the 1 is. So in this case, 10 to the minus 2, the 1 is 2 places to the right of the decimal. Here, 10 to the minus 3, the 1 is 3 places to the right of the decimal. So in this case, I have a 1 that is actually 27 places to the right of the decimal. So I can write the mass of a proton as 1.673 times 10 to the minus 27 kilograms. And this 10 to the minus 27 has the function of putting this number, 1.673, 27 decimal places to the right of the decimal point.
So scientific notation is a way of reformatting very big or very small numbers to make them easier to work with. It's always an expression of numbers in the form m times 10 to the n, where 1 is less than or equal to m is less than 10, and n is an integer. It's easier if we just look at the notation. So here is a number in scientific notation. At the beginning, we see a coefficient, the number that's greater than or equal to 1, but less than 10. That's called the coefficient. The second part of scientific notation is where we multiply that number by 10, or it's also called the base. And we use 10 because it's easier. And we raise that 10 to some power or exponent, and that's called the exponent. The coefficient always has all the significant figures in the measurement that you measured. Always. The coefficient always contains all of the significant figures, and it always follows the rule that it's greater than or equal to 1 and less than 10. The base is always 10 because 10 is really easy to multiply and divide by, and multiplying and dividing by 10 is just like moving a decimal point. Lastly, there's the exponent, and the exponent is always some integer. We raise 10 to the power of some integer to tell us how far we should move that decimal point. If the number we're reformatting is really large, the exponent is positive, and then if the number we're reformatting is very small, the exponent is negative. Now it's your turn. Pause the video and see if you can put these numbers, these big and very small numbers, into scientific notation. So you didn't really think I was going to leave you hanging. I'm going to rewrite that number here on my piece of paper, that 3401 and all those zeros after it. Make sure I've got them all. Okay, and then I'm going to take the first significant figures, the numbers at the beginning, and I'm going to rewrite it in the form that is less than 10 and greater than or equal to 1. Then I put in the base, which is the same for every scientific notation. Now comes the fun part, and I count all the zeros from the end all the way up to see how far that decimal place will have to move. Turns out it's 21. Now let's look at a really small number. That's the second number in that practice list. So here's a very small number. Again, I'm going to take the two significant digits and rewrite them in the form of between 1 and 10. Then I'm going to put in my base. And now I'm going to count how many places that decimal place has to move to get in between the 1 and the 6. And because this is a little teeny tiny number, we know that the exponent is negative. How about another big number? 56231 followed by 6 zeros. Yeah, that's a good number. Again, take the significant digits in the number, rewrite them in the form greater than or equal to 1 and less than 10. Multiply by your base and do some counting. See how far that decimal place has to move to get between the 5 and the 6. One last tiny number for us here. 0.0042541. I'm going to again take those significant digits, all the significant digits, and rewrite them in the form greater than or equal to 1 and less than 10. Multiply by the base. Then do some counting. How many places does that decimal place have to move before it gets in between the 4 and the 2? 8. Again, it's a small number, so it ends up being negative. If you are able to follow along with that, that's awesome. Good. You're well on your way to understanding scientific notation. But now let's see if we can go the other way. So again, pause the video and see if you can reformat these scientific notation numbers into standard notation. Here's our first number, 3.162 times 10 to the 14th. First, expand out your coefficient. Take that decimal away. We got to move that decimal 14 places to make this a really big number, so I'm going to put underscores under each of the 14 places. Any place there's not a number above the underscore, I'm just going to put a 0. Now I have a really big number, which makes sense because this number, this exponent, is positive. The second one, 1.2 times 10 to the negative 8th, is a very small number. So now I'm going to have to go the other direction to make this little. And I'm going to count 8 places from where the decimal was. Put in my zeros and a decimal, and voila! Now how about this one, 9.31 times 10 to the first power? Well, this one is crazy because what is times 10 to the first power? Well, that's just the same as multiplying by 10. So now I have 9.31. I'm going to expand my my coefficient here. And where do I need to put that decimal? Well, I just need to put it one place over, one place bigger from what it was. Well, that wasn't so bad. As you can see, I skipped the last one, but there's the answer to it. The video's getting long. Let's see what else we can do with scientific notation. Scientific notation actually makes it a lot easier for us to do math with really big and really small numbers. Now, the first mathematical operation that I want to talk about is multiplication and division. When you multiply in scientific notation, you use this standard rule. N times m to the 10a plus b. I'll show you how to use it here in a second. And then if you want to divide in scientific notation, you're going to do n divided by m times base 10 a minus b. So you see how that's working out? And at the end, after you've done a multiplication or a division, if your coefficient does not fit the rule for coefficients, that is, it isn't greater than or equal to 1 or less than 10, fix it, which means that you also have to fix your exponent. Your turn to try. Remember that you can always go back in a YouTube video and look at the rule, write it down, and try these out. So here's our first multiplication problem here. I've got 5.1 times 2.5. And remember, we're going to take the coefficients, multiply them together, then take the exponents and add them. So now we can just do a little math here, either in our head or in our calculator, and do 5.1 times 2.5, which is 12.75, and times 10 to the 4 plus 3, which is 7. Now 12.75 does not meet the rule of coefficients. It's not greater than or equal to 1 and less than 10. Specifically, it's not less than 10. So we need to move that decimal place one place over to get it 1.275. Now this should be 10 to the 8th is what this should be. The other thing we need to look at here is that there are only two significant figures in each of our measurements. There we go, 10 to the 8th. Two significant figures in each of our measurements, so we can only have two significant figures in our answer. So that would be 1.3 times 10 to the 8th. How about this one? We have a division problem now, which means that first we need to divide the coefficients. 3.66 divided by 2. Then we're going to subtract the exponents. -5 minus -3. 3.66 divided by 2 is 1.83, and -5 minus -3 is -2. Now again, look at the significant figures. Well, we can only have 2 in our answer, so our answer is 1.8 times 10 to the -2. Ooh, doesn't this one look scary? Well, it's not too bad. We just got to do it in 2 steps. So in the first part, we have a multiplication problem. Multiply the coefficients, times by your base, and add the exponents. Hey, that's not so bad. 8.2 times 5, that's going to be 41, times 10 to the 6 plus -2 is just 4. Now I'm not going to change it into scientific notation yet because I have one more step. I need to divide by 2. So 41 divided by 2 times your base, and then you subtract the exponents, 4 minus 2. Now 41 divided by 2 isn't so bad. I mean, you could almost do that in your head, right? 41, I mean, you know what 40 in half. So it's going to be 20.5, and then 4 minus 2 is 2. Now again, this does not meet the rule for coefficients, so we have to move that decimal place over 1 to get it into the correct scientific notation. Now wait a minute, there was some deal with significant figures you talked about earlier. Oh yeah, look. Each of those numbers in our problem only have 2 significant figures, which means that we can only know our answer to 2 significant figures, which means our answer has to be 2.1 times 10 to the 3rd. We're really clipping along now. You should have got all those answers, and you're ready to learn something else about scientific notation. Now usually when you learn math you always start with addition and subtraction, but in the case of scientific notation it's harder than multiplication and division because there's not any rule. You just have to rewrite the coefficients so that the two numbers have the same exponent. Then do the math. It's easier if I just show you. So now my turn to do some math, right? And show you how to do these additions and subtractions. So get out a piece of paper. Here we go. Now remember, in addition and subtraction, we just have to rewrite the numbers so that they each have the same exponent. So my first number is 2.82 times 10 to the 4th, and my second number, 1.5 times 10 to the 3rd, I'm going to rewrite so that it's 0.15 times 10 to the 4th. Then I can just add 2.82 and 0.15. Watch out for those significant figures. They'll get you every time. We're going to do this one now. 3.66 times 10 to the -5th and 2.0 times 10 to the -3rd. Well, I'm going to change my -5th to a -3. So that means I have to move the decimal place over twice. So now I have 0.0366 times 10 to the -3 and the other one. Now I just subtract 2 from 0.0366 to get my answer. And again, this is exponent is going to be -3. But watch those significant figures. Once again, now it's -2.0 times 10 to the -3rd. Does it make sense? Yes. 8.2. times 10 to the negative 1 plus 5.0 times 10 to the 1. Okay, so I'm going to rewrite 8.2 so that it is in the form 10 to the 1, so that both of them are in 10 to the 1. And when I add these two together, it's easy. I can just look at them and I can add them. But again, significant figures, we're going to do some rounding here and get our answer. Now the best thing I can show you is how to do this on your calculator. So first type in your number. Then to do your times 10 to the, you need this EE down here. See the little yellow EE? So we do second function E, and then we put our exponent. Now we can add, subtract, multiply, or divide just from there. Again, 5.0 EE, we want that EE, so we go second E and put in our exponent. Now we are adding 8.2 times 10 to the negative first and 5.0 times 10 to the 1, and we get 50.82. So there's your answers from the addition and subtraction. Remember that you can always pause, go back, rewind, play again, and get all of these things over and over again. And definitely check out that calculator trick because it'll save you a lot of time. So that's scientific notation. It always has the same form with a coefficient, a base, and an exponent. It's really helpful with big and tiny numbers, and it makes math problems with big and small numbers more manageable if you follow the rules and if you use your calculator. That's it. That's scientific notation. Thanks so much for watching. If you have questions, you can comment below, send me an email, or see me in class. We'll see you later.